Measuring temperature with a thermocouple may seem simple, but getting an accurate reading, especially from a surface, requires understanding how heat moves through a system and how mounting techniques, material properties, and ambient conditions influence the result. One of the most common issues engineers encounter is the difference between surface temperature and internal or process temperature. If this difference isn't accounted for, surface measurements can appear inconsistent, unstable, or simply wrong. Whether you're monitoring a pipe, a heating element, an engine component, or industrial equipment, understanding how a surface-mounted thermocouple behaves and how that differs from an insertion probe is essential for collecting meaningful data. When you attach a thermocouple to the outside of a component, it measures only the surface temperature, but the surface almost never matches the temperature of the internal fluid or material. This difference is driven by several factors. Thermal gradients. Any system that moves from a hotter region to a cooler region forms a temperature gradient through the material. A hot fluid inside a pipe may be hundreds of degrees hotter than the exterior surface. A surface-mounted thermocouple sits at the outer end of that gradient, which means it reads cooler than the true process temperature. Material thermal conductivity. Different materials behave differently. Metals conduct heat well, reducing the difference between internal and surface temperatures. Plastics, composites, painted surfaces, and coatings restrict heat flow, creating larger temperature offsets. Knowing the material helps determine whether a surface measurement is meaningful or only loosely correlated to the process temperature. Insulation and wall thickness. Thicker walls or insulated systems shed heat before it reaches the outside surface. A thin stainless pipe may have minimal difference, while a thick insulated steam line can show a huge temperature disparity. This is why immersion thermocouples are used in many process industries. They eliminate the offset by directly contacting the internal medium. Influence of ambient temperature. One factor that's often overlooked is ambient temperature, the temperature of the air or environment surrounding the equipment. Surface-mounted thermocouples are directly exposed to ambient air, so they are influenced by airflow or wind, convection currents, radiant heat from nearby components, enclosure temperature, and seasonal or weather changes. In motorsports and outdoor industrial applications, ambient influence can shift readings by tens of degrees. Mounting method and thermal contact. Even when surface temperature is the intended measurement, the mounting method significantly impacts accuracy. Adhesive-backed sensors are fast, but the adhesive layer can add some thermal resistance. Epoxy or thermal compound improves thermal coupling and reduces ambient influence. Clamping or bolting is strong, provides consistent contact, and is best for vibration or high temperatures. Welded pads provide excellent heat transfer, but require proper material compatibility and welding expertise. Good thermal contact helps anchor the sensor to the object's true surface temperature and reduces the influence of ambient conditions. Choosing the right thermocouple for surface measurements. Surface measurements require the right design. Surface pad thermocouples for a flat or curved surface. Miniature adhesive sensors for electronics or R&D applications. Washer or ring thermocouples under bolts or fasteners. Exposed junction thermocouples for fast response if held firmly in place. Using the correct geometry helps reduce signal noise, improves response time, and increases measurement stability. When surface measurement is not enough, if your goal is to measure the true process temperature, the actual temperature of a liquid or gas inside of a pipe or vessel, a surface-mounted thermocouple is generally not recommended unless no other option is available. In those cases, use immersion or insertion sensors or penetration probes. Surface readings give valuable information about system health, heat loss, and thermal behavior, but they cannot replace internal measurement when precision is required. Thanks for watching. If you enjoyed this video, please subscribe and click the bell to turn on notifications so you never miss an update. For additional pricing and technical questions, contact us now at hgsind.com. Harold G. Shavitz Industries. Performance and reliability is our business.